We're going to take the Pythagorean identity that the sine squared plus the cosine squared of any angle is equal to 1. We're going to prove it, and we're going to use it. The Pythagorean identity says that the sine squared of an angle plus the cosine squared of the angle is equal to 1. Well, why is that true? Let's take a look at the unit circle. And if we look at any point along the unit circle, and I've picked a convenient one, we're going to see why this is true. And of course, you know that coordinate point, point 8, point 6 in this case, forms a right triangle with the positive x-axis and the center. And the x-coordinate winds up being the cosine because it's adjacent over hypotenuse. Hypotenuse is 1. Sine becomes the y-coordinate because opposite over hypotenuse, and the hypotenuse is 1. So our x and y coordinates become the cosine and sine of theta in this case. So why is it that the sine squared plus the cosine squared equals 1? Well, let's test it out on this particular angle, and we're going to see that since the cosine is 0.8 and the sine is 0.6, 0.6 squared plus 0.8 squared equals 1. Well, that's true. But is it true in other places? Well, if we look at other places along the unit circle, you can pick any at random, and you can pick them at any quadrant. Okay, let's just pick another one down here at random. Okay, this point, negative 0.7444, negative 0.6677 in the third quadrant, where sine and cosine are both negative, forms a reference angle of 41.9 degrees. So it would be a total theta angle of 221.9 degrees. Well, if we check this out, the sine is the y-coordinate, the cosine is the x-coordinate, we square them and we add them, we get 1 again. So it seems to hold true, and in fact you can experiment and try this in every place on the unit circle and beyond, and this thing will work. So the big question is why? Why is it that the sine squared plus the cosine squared is always equal to 1? Well, take a look at what we've got here. This is a right triangle. What's true in a right triangle? Well, the two legs squared added together always equal the hypotenuse squared. Well, on the unit circle, the cosine of theta is one of the legs, and the sine of theta is the other leg. So it follows that the cosine squared plus the sine squared have to equal the hypotenuse squared. And since the hypotenuse is 1, the Pythagorean identity flows smoothly to say that cosine squared plus sine squared equals 1. So here's an example problem. Let's work this. If you're given that the sine of theta is 2/7 and the angle is in quadrant 1, find the cosine of theta. Now previously you worked this problem by drawing a triangle, trying to figure out that the hypotenuse must have been 7 and the opposite side 2, and then worked out the adjacent side that way. And really, the Pythagorean identity will help you do this, and it's the same process, but it's a shortcut. Let's use the Pythagorean identity to solve this quicker. Okay, so let's look at the Pythagorean identity. Sine squared plus cosine squared of the angle equals 1. So since we know that the sine is 2/7, we'll plug in a 2/7 for sine theta. That squared plus the cosine squared has to equal 1. So if we simplify 2/7 squared, we get 4 over 49 plus the cosine squared equals 1. Well, using algebra, we're going to subtract that 4/49 from both sides because we're trying to isolate theta. And what we're left with then is the cosine of squared equals 1 minus 4 over 49, or 45 over 49. We then take the square root, and so we get the cosine of theta is equal to the square root of 45 over 49 by taking the square root of both sides. And that either boils down to 0.9583 approximately, and remember we're always going to take those ratios to 4 decimal points if we're using decimal, or the square root of 45 over 7 in radical form. Of course, the square root of 45 can be simplified down to 3 square roots of 5, and then so your answer in radical form is 3 square roots of 5 over 7. So let's work another example in quadrant 3. Don't forget, we're going to have to change the sign from positive to negative because it is in quadrant 3. So given that the cosine is negative 15 over 26 and the angle's in quadrant 3, find sine of theta. Of course, we know that sine squared of cosine squared equals 1. So we're going to plug in negative 15 over 26 for the cosine of theta and square that. So the sine squared plus that number squared, which is 0.3328, notice it's positive, is equal to 1. These are always going to be positive numbers after you square them, because any number squared is positive. We're going to use algebra and subtract the same number from both sides, giving us that the sine squared of theta is equal to 0.6672. And then taking the square root of both sides, we get that the sine of theta is the square root of 0.6672, approximately 0.8168, but it's in quadrant 3, so the sign has to be negative. So now you know where the Pythagorean identity, sine squared theta plus cosine squared theta equals 1 comes from, and you know how to use it.